The strongest storm on Earth. Here's what scientists are saying. On October 12, 1979, a weather buoy in the Pacific stopped transmitting. Not because it broke, because the storm bearing down on it had a barometric pressure so low, so violent, that instruments simply could not register what was happening around them. What formed that week would become the most intense tropical cyclone ever recorded on planet Earth. Its name was Typhoon Tip. And what scientists learned from it, and from every monster storm since, is reshaping how we think about the most destructive force our atmosphere can produce. This is the story of the strongest storms on Earth, where they come from, why they're getting worse, and what's coming next.
The anatomy of fury. To understand the strongest storm on Earth, you first have to understand what a storm actually is. Not clouds, not rain. Energy. A hurricane, or typhoon, or cyclone, depending on which ocean you're standing beside, is a heat engine. It pulls warm, moist air off the ocean surface, sends it spiraling upward, and lets it cool and condense at altitude, releasing enormous stores of latent heat. That heat powers the winds. The warmer the ocean, the more fuel there is to burn. This is why storms are born near the equator, in a band of ocean where surface temperatures regularly climb above 26 degrees Celsius, the rough threshold scientists use as the minimum for cyclone formation. Below that line, a storm can't sustain itself. Above it, especially well above it, a storm can explode. And explode is the right word. Meteorologists have a term for it: rapid intensification. It's defined as a jump in sustained wind speed of at least 35 miles per hour in 24 hours. It sounds almost bureaucratic, a number on a chart. In reality, it means a storm that was a manageable tropical system at breakfast can be an unrecognizable monster by dinner. Typhoon Tip experienced exactly this. In under 24 hours,
Here's where it gets complicated, and where the myth-busting begins. Strongest isn't one number. Scientists measure storms differently depending on what they're trying to capture. If you measure by wind speed, the title goes to Hurricane Patricia, which in October 2015 spun up off the coast of Mexico with sustained winds estimated at 215 miles per hour, the strongest ever reliably measured in the Western Hemisphere. Patricia intensified so fast that forecasters ran out of adjectives. Some internal advisories simply called it potentially catastrophic. If you measure by central pressure, often considered the more physically meaningful metric since it reflects the total energy of the system, the record still belongs to Typhoon Tip at that almost unbelievable 870 millibars. If you measure by size, again, Tip. If you measure by total destructive energy over its lifetime, a metric called accumulated cyclone energy, some multi-week Pacific typhoons that never hit peak wind records still outrank Patricia and Tip combined, simply because they stayed powerful for so long. So when someone tells you definitively which storm was the strongest, the honest scientific answer is strongest by what measure? This isn't a technicality. It's the difference between a storm that's a brief, catastrophic spike and one that's a sustained, grinding engine of destruction for 2 straight weeks.
Why the ocean is the real story. None of these storms formed in a vacuum. They formed because the ocean handed them fuel. Here's what climate scientists have been documenting for years, methodically, storm season after storm season. The upper layers of the world's oceans are warming. Not dramatically year to year, but persistently, decade over decade. And that warming doesn't just raise the average temperature of the water a storm passes over. It deepens the layer of warm water beneath the surface. That deep warm layer matters more than people realize. A storm's own churning normally drags cold water up from below, which acts as a natural brake. Cooler water beneath the eye can choke off a storm's fuel supply and weaken it. But when that cold layer is pushed deeper, storms lose their built-in speed limit. They can keep pulling from a nearly bottomless reservoir of heat, and that's when rapid intensification becomes not just possible, but common. This is the pattern researchers have flagged with increasing urgency. Not necessarily more storms overall, but a rising share of storms that intensify explosively right up to landfall, leaving coastal communities almost no time to evacuate. Hurricane Harvey, Hurricane Michael, Hurricane Ian. Storms that were moderate one day and catastrophic 24 to 36 hours later.
The storm that's coming. Every hurricane season now, forecasters watch the same numbers scientists have watched for decades: sea surface temperatures, atmospheric moisture, wind shear. And increasingly, those numbers point in one direction: warmer oceans, more available energy, a wider window for a storm to find the ideal conditions and detonate. Scientists aren't claiming every future storm will break Tip's pressure record or Patricia's wind record. Records are rare by definition. What they are saying, consistently across dozens of peer-reviewed studies, is that the ceiling is rising. The theoretical maximum intensity a storm can reach, something meteorologists calculate using ocean heat content and atmospheric conditions, is climbing in most of the world's tropical cyclone basins. That means the next record breaker isn't a matter of if, it's a matter of when, and where it makes landfall when it happens. And that last part is the real danger. Tip spent most of its life over open.
The legacy of the numbers, what Typhoon Tip and Hurricane Patricia really left behind, isn't just a record in a textbook. It's a warning system. Every buoy reading, every dropson dropped into an eye wall, every satellite passed through a storm's spiral bands has been building, storm by storm, a model of what our atmosphere is capable of. And that model keeps getting revised upward. The strongest storm on Earth isn't a single event frozen in 1979 or 2015. It's a moving target. And the scientists tracking it aren't just looking backward at what already happened. They're watching the ocean right now, waiting to see where and when the next name gets written into the record books. If this kind of deep dive into the forces that shape our world is something you want more of, subscribe. Because the next storm on the record books is already forming somewhere over